Alright, so 7.7 notes. Our goal for today is going to be to solve equations containing radicals. So, when we go to solve equations that have radicals in them, okay, you can see in our three examples what it means is that it has this radical symbol here. It has a radical symbol here. The notes are on the counter over there. It has another, this one here, it doesn't have a radical symbol, but tell me, why is this a radical? It has a fraction exponent. So really, this is which root? What root is this that we're taking? It's the fourth root, since that's what's in the denominator. Okay? That's why it was important that we knew how to convert between exponents and radicals on that quiz we took today. I'll have you take yours after lunch. Alright, so when we are going to solve these, the first thing that we're going to do is we're going to isolate the radical, or the group that has that fractional exponent, on one side. So we're going to get the radical alone. Then we're going to raise each side to a power that's equal to the index. Okay? And then what you'll do is you'll solve the polynomial. That's why it's important that we knew Unit 6, because now you'll have a polynomial to solve. And then you're going to check for those solutions that sometimes just don't work. Does anyone remember what those are called? Starts with an E. EX. Extraneous solutions, yes. They come up in these problems, so we have to make sure we check for extraneous solutions. All right. Now, the first thing that we're going to do is we're going to get the radical alone. So, pretend like this here, where the radical is a variable. If you need to make it into a simpler problem, you could do that. You could use kind of like U substitution. And we could instead pretend that this said something like y plus 10 equals 7. What would we do to get y alone? Subtract the 10. We would have the y equals negative 3. Well, the y was just standing for that radical. So if you need to make it into a problem that looks more familiar to you, you can do that and then switch it back and say the radical equals negative 3. I don't mind leaving it, but if that looks confusing to you, then you're more than welcome to change it to a simpler problem or think about it as a simpler problem. Okay. We got the radical, we have the radical alone. Okay, we isolated it to one side. That's what step 1 said to do. Step 2 says to raise each side to a power equal to its index. So this one has an invisible index. What is the index that is invisible here? 2. A 2. So I'm taking a square root. How do I undo square rooting something? I would take it to what power? It says to raise each side to a power equal to the index. What's the index here? So we're going to raise both sides to the power of 2. Let me find a different color. Because what happens when you square a square root, the square root and the square cancel, and what we're left with is x plus 2 equals, what is negative 3 squared? 9. Are we okay with what we did? Now, that's just a polynomial. More specifically, it's a linear. How do we solve that? Subtract 2 on both sides. Now, when you go to do this assignment, you'll want to have a spot where you write solutions. And you'll notice that this is how it's written once we get to the review. But I expect that you guys can write this out before then. Okay, you'll have solutions and extraneous solutions. We have to figure out where this goes. Is it a solution or is it an extraneous solution? It cannot be both. It will never be both. Because an extraneous solution is not a solution. So it can't be a solution and not a solution. It can't be both. Okay? It's like saying I'm tall and short. Definitely not true. I can't be both. I am definitely short. So, we have to check and we have to plug in our solution that we got to see which one it's going to be. So we take our original, the square root of x plus 2. Guess I didn't need my radical sign quite that long. Plus 10 equals 7. And the x that I found was 7, so that's what I'm going to substitute in. 7 plus 2 is 9, so I'm just going to use PEMDAS here and simplify the left side. What's the square root of 9? What's 3 plus 10? What was the right side? There was nothing to simplify on the right side. Does 13 equal 7? No. So where do we write our answer over here? Is it a solution or an extraneous solution? This one's extraneous, so we're going to write x equals 7 on the extraneous solution line. And for the solution, we say there is no solution. Or you can write not available there. But we have to make sure that x is 7 is on our extraneous solution line. Are we okay with that? All right, let's try the next one. All right, I need to get the radical alone. So here's my radical. I have 3 times the radical minus 2. Again, if you want to change it to something that you're more familiar with, change it to like 3y minus 2 equals 0. And what would I do to get the y alone, or where my finger is alone? I would add 2 to both sides to begin. Now I have 3 times something equals 2. What do I do to both sides? Divide by 3. I'm just going to write this as 2 divided by 3 over here. I write it as the fraction. I'm not going to try to write anything as decimals because we know that we don't deal with decimals in this class unless we're asked to type it in our calculator and estimate. Are we okay up to this point? Okay, so that was step 1. We isolated the radical on one side. We have the radical alone. What's step 2 say to do? Yes, we're going to raise both sides to the power of the index. What is the index here? 3. So we're going to take both sides and raise it to what power? 3, because the index was 3. If you cube root something and then cube it, it undoes it. You can even try it in your calculator. If you were to take something like 7 and take it to the 3 over 3 power, what's 3 over 3? 1. You're just taking it to the first power. Because remember that index is the denominator, right? So the power is technically 3 over 3. That's just 7. It doesn't change it. Okay? Or if we wanted to go get fancy here, there's the cubic root of 7 to the third power, we still get 7. You're not changing. If you take something to a cube root and then you cube it, they undo each other. You're back to what you started with. So when we take the cube root and you cube it, they undo each other, and on the left side, we're left with 5y minus 1. On the right side, what is 2/3 cubed going to be, or how do I do this? Yes, it is technically 2/3 times 2/3 times 2/3, but on the top, all you're doing is 2 times 2 times 2, or 2 to the third power. So what number are you getting on the top if you're taking 2 to the third power? 8 on top. What is 3 to the third power on the bottom? Because if you write it out, you're multiplying across the bottom, you'd have 3 times 3 times 3, or 3 to the third power, which is 27. Can 8 over 27 reduce? No, you could check in your calculator if you're not sure. That fraction, hit the math button to a fraction, 8/27. Nope, doesn't reduce. If you have the purple calculators, you hit second and that PRB button, and then second and the fraction button, and it would convert it to a fraction for you. So if you want to show you that. So to convert to fractions on this one, 8 over 27, that's the decimal. Hit second, the PRB button, which above it you can see it says fraction to decimal, decimal to fraction, F to D. Enter, it converts it to 8 over 27. We don't have to hit the other one because it's already there, but most of the time you'd have to hit second and then the fraction button, because that'll change it back to an improper fraction versus a mixed number if you got a mixed number there, which we never deal with mixed numbers either in this class, so everything's always improper fractions. So 8 over 27 is our fraction there. Okay, now we have to solve for y, though. What am I going to do? Add 1 to both sides. The version of 1 that I would choose to add is probably 27 over 27. Why did I choose to do that? Because I need a common denominator when I'm adding fractions together. So I have 5y on the left is equal to 8 and 27. It's 35 over 27. What comes next? Divide both sides by 5. If you're dividing, it just goes in the denominator. So when I divide by 5, I'm just going to have 35 over 27 times 5. I divided this also by 5. Not only am I dividing by 27, I'm also dividing by 5. That's times. So 27 times 5. 135. Thank you. Now I can reduce this. Again, you can use your calculator and reduce it. 35 divided by 135. Second, that fraction, decimal to fraction. 7 over 27. It's not a mixed number, so I can use that. If it was a mixed number, I would hit second and this fraction button, and it would convert it to 7 over 27. Now, I have to figure out, is this going to be a solution, or is this going to be an extraneous solution? And in order to figure this out, I will have to plug it back in. I don't think I gave you any that are this nasty of fractions on your assignment, so. 3 times the cubic root of 5 times 7 over 27 minus 1 minus 2 on the outside equals 0. what am I going to do first? Go ahead. I'm not doing anything to each side. I don't want to move stuff from side to side. I want to see, does this side equal the right side? So you think of this as an expression. Don't think of it as an equation. So only looking at the left side. What are we going to do first to simplify that left side? Yes, multiply 5 times 7 over 27. So we have 3 times the cubic root of 5 times 7 is 35 over 27 minus 1 minus 2 on the outside. Then what? Now we're going to have to subtract the 1. We have to do what's under here first because we have to think about this is underneath parentheses. This represents that this is all grouped together under parentheses. So parentheses and PEMDAS comes first. So what is 35 over 27 minus 1? Well, I can actually erase this and just write in 27 over 27. So 35 over 27 minus 27 over 27. What's the number on top? What's 35 minus 27? 8 over 27 minus 2 on the outside. Okay. Well, this isn't actually too bad because I can take the cubic root of 8 and I can take the cubic root of 27. Both of those numbers are perfect cubes. What is the cubic root of 8? 2. So I have 3 times 2 on top. What is the cubic root of 27? 3. What's 3 times 2/3? Or 3 times 2 divided by 3? 6 over 3, which is 2. So now we have 2 minus 2, which is 0. Does 0 equal, on this other side I had 0 all along. Does 0 equal 0? Yes. So is this going to be a solution or an extraneous solution? This is a solution. So we're going to write y equals 7 over 27. That's the solution that we got. Right there. We're going to write it under a solution. And for the extraneous, we're just going to write NA, not available. Do we have questions? Yes.
So, for the first one, why do you say equal to 7, but the second one you say equal to 6?
I used the equation that was given to me.
Oh.
This one was set equal to 0. This one was set equal to 7. So that's how you're going to set up that very first step. The only thing different is we now have an idea of what's y and what's x. That's the only thing we plug in.
Okay, yeah, I didn't look at that.
Okay. Are we good?
Yeah. Oh.
Other questions? All right. Should we try the last one? Okay. We have 4 times a radical minus 108 is equal to 0. What's the first thing I'm going to do to get my radical alone? Add the 108 to both sides. So I have 4 times the radical equals 108. Okay, 4 times the radical equals 108. Well, how do I get the radical alone? Divide by 4 on both sides. So I have the radical by itself now. And 108 times 4 is 432. Oh, sorry. Yeah, we're dividing, not multiplying. Duh. What is it, 27?
Yeah.
Thank you. 27. Okay, now we have to take it to a power equal to its index. What's the index here?
4.
So we're going to take it to the 4th power, but we have something else going on. What do we want our exponent to be when we get rid of the radical? What is our exponent when we got rid of the radical? Our exponent is 1, right? when you had something that was an index, so it was taken to the power of 1/3, we then took it to the power of 3, because 1/3 times 3 is 1. When it was being square rooted, our power was 1/2. We took it to the second power, because 1/2 times 2 is 1. Are you with me? Okay, so let me show you what I mean by that. This first one, we had something to the power of 1/2. We took it to the power of 2, which made it to the power of 1. Right? 1/2 times 2 is 1. Or it's 2 over 2, because you multiply powers to powers. 2 over 2 is 1. Okay, so far? In the next one, it was a cube root, so we had something to the 1/3 power. We then took it to the power of 3, or 3 over 1, however you want to look at it. We then had a power of 3 over 3, which is, again, the power of 1. Are you with me? If I have something to the power of 3/4, because that's what I'm dealing with now, what could I take it to the power of to get to the power of 1? 4 over 3. Very good. How did you come up with 4 over 3? You flip it. It's the reciprocal. 2 over 1 is the reciprocal of 1/2. 1/3 and 3 over 1 are reciprocals. 3/4 and 4/3 are reciprocals. If you multiply 3/4 times 4/3, you get 12 over 12, which is equivalent to 1. Do you see that? So we did some parts of this one, where we got the radical alone. What power are we going to take both sides to? 4 over 3, because we use the reciprocal. Okay. 3/4 times 4/3, because powers to powers multiply. On the left side, I'm going to be left with 3x plus 6. On the right side, let's put that in our calculator. 27 to the power of, remember to put 4/3 in parentheses. This is one of the biggest issues people are having, are they're taking it to the 4th power and then dividing by 3. They're typing it in like this. PEMDAS tells you to apply the exponent, so do 27 to the power of 4, and then take that answer and divide by 3. We don't want to divide by 3 afterwards. We want it to be to the power of 4/3. That answer is 81. Are we okay with that? Okay. You could also do it in 2 steps. You could take 27 to the power of 4 and then cube root that if you wanted to do it in 2 steps. Either way, I think you guys are pretty good at solving something that looks like this. What do you do first? Subtract the 6. 3x equals 75. What comes next? Divide by 3. X equals 25. Now we have to decide, is this going to go on the solution or the extraneous solution line? So we go over here to where we're going to check. 4 times 3 times 25 plus 6 to the power of 3/4 is supposed to equal 108. All I did was put x in up here to this equation. 4 times 3 times x plus 6 to the power of 3/4 minus 108, sorry. Not equals 108. Equals 0. Okay. All right. What do I do first? The inside of the parentheses, 3 times 25, which is 75, plus the 6 to the power of 3/4 minus 108. 75 times 6, or 75 plus 6 is 81. Now that I've taken care of the parentheses, PEMDAS says to take care of the exponents. Remember, radicals are exponents, right? So they apply at the same time. So 81 to the power of 3/4. Do that on your calculator.
27.
What is it?
27.
27? Did we all get 27?
Yeah.
Okay. Then what do? 4 times 27 is 108 minus 108, which is 0. It's supposed to equal, on the right side we have 0. Does 0 equal 0? So where does the answer x equals 25 go? This is going to be a solution. There's nothing for an extraneous solution then. Okie dokie. Cool beans.